Welcome you all to the course Database Management System. Myself, Mohammad Asifuddin Mondol, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. And this is lecture number 35 of this particular course. In this lecture, I am going to cover chapter number 8, which is concurrency control. And these are the topics which I am going to cover during this lecture. I will discuss the concept of graph-based protocol, the graph-based protocol, and then I will discuss the tree protocol, and these are the protocol by which we ensure the conflict serializability, and then I will discuss about the concept of timestamp based protocols. Now, before going into details of the graph based protocol, just recap two-phase protocol. First of all, the two-phase locking protocol, the main purpose is to ensure conflict serializability. Graph based protocol, this is the another protocol, and the objective is same. With the help of graph based protocol, we have to ensure conflict serializability. That means with the help of two-phase locking protocol as well as graph based protocol, these two protocols are responsible to ensure conflict serializability. But differences are there. In two-phase locking protocol, what we have done, any transaction which is going to access a data item, first they have to lock a data item, and once the work has been done on a particular data item, then lock has to be released by the transaction. And this locking and unlocking of data item by a transaction must be happen in two phase, in growing two phase. So the first phase is the growing phase. In the growing phase, transaction may only obtain the new locks, no lock can be released. And second phase is the shrinking phase. In that phase, transaction can only release the locks, cannot obtain any new lock. So locking and unlocking of the data item by a transaction must happen in two phase. It is the concept of two-phase locking protocol. But graph-based protocol is not like that. In graph-based protocol, data item may be locked and unlocked at any given point of time. That means graph-based protocol is not a two-phase kind of thing. Locking and unlocking may be happen in any point of time. So it is not a two-phase locking type protocol. But one thing which is extra in graph-based protocol is that to implement graph-based protocol, we need additional information on how the transaction are going to access the data items. Specifically speaking, the database management system or the concurrency control component require additional information, means the order in which a transaction is going to access all the data item. That means in graph-based protocol, the concurrency control component needs the additional information. And what is the additional information? It needs the order of the data item by which a transaction is going to access the databases. Suppose multiple data item is going to be accessed by a transaction, but here we need the order by which transaction is going to access all these data items. So this ordering is very much important. So this additional information is required to implement graph-based protocol. If this additional information is not there, then we cannot implement graph-based protocol. Then we have to use the two-phase locking protocol. So for the partial ordering, we need to maintain the set D. This is the set D, which is equal to d1 d2 dot dot dn, and d1 d2, these are the data item that is going to be accessed by a particular transaction. So that set need to be maintained by the database management system. Not only set is need to be maintained, apart from that, partial ordering has to be maintained by the database. Now partial ordering is denoted by in that form di arrow dj. Let me mark with it. So first thing, we need to maintain the data set which is going to be accessed by a particular transaction, and then we need to maintain the partial ordering of this data item. Now partial ordering is represented in that form di arrow dj. This is the partial ordering representation. Now we can write di arrow dj if any transaction accessing both the data item di and dj, and if the ordering is like that, then transaction first have to access di, then only transaction can access dj. So again I'm repeating, if the partial ordering is like that, di arrow dj, then transaction first have to access the data item di, then only transaction can access the next data item dj. So that kind of partial ordering has to be maintained by the database management system. Now this kind of partial ordering have to be represent, how to represent that kind of ordering. Now that kind of ordering is represented with the help of database graph. So in graph based protocol we need a graph which is known as database graph, which is a directed acyclic graph. And that database graph, what is the purpose of that database graph? With the help of that database graph, we are going to represent the set of data item that is going to be accessed by a transaction, as well as with the help of database graph we are going to represent the ordering of the data item by which a transaction is going to access them. So we have to first build a database graph. Once the database graph has been built or completed, then we have to devise a tree protocol, and the tree protocol will access the database graph, and then it ensures conflict serializability. So let's look how database graph looks like and what is the tree protocol in the next slide. So the database graph, it should looks like the picture shown here. This is the database graph where A, B, C, D, all these vertices represents the data item which is going to be accessed by the transaction, and these are the edges. A arrow B means if transaction want to access data item A and B, then transaction first have to access A, then only can access B. So this is that is how database graph can be represented. Now once database graph is completed, what we have to do, we have to implement the tree protocol. Tree protocol will read the database graph and ensure the conflict serializability. Now what is tree protocol? We need some assumption has to be made for tree protocol. First thing, in tree protocol only exclusive mode of locks are allowed. Again I'm repeating, in tree protocol the assumption is only exclusive mode locks are allowed, and another assumption is that in tree protocol a data item is only be accessed by only once, only be logged by only one times. Data item are logged by only one times. So these are the two assumption is being made. Now what are the rules of tree based protocol? The first rule is that the first lock by transaction Ti may be on any data item. That means a transaction Ti, while it start execution, that initially lock any data item. Second, in the second time onwards, means subsequently a data item Q can be locked by transaction Ti only if the parent of Q is currently locked by Ti. That means, suppose consider the example, suppose transaction Ti wants to lock data item F. So transaction Ti can lock the data item F only if the parent of F is currently logged by Ti. That means the parent of F is B. So F can be logged by Ti only if B is also logged by transaction Ti. Otherwise transaction Ti cannot log the F. Third rule is the data item may be unlocked at any point of time. That means it's not like a two-phase locking protocol where you can only unlock the data item in the shrinking phase. But here tree-based protocol, data item can be unlocked by transaction at any given point of time. And next rule, a data item that has been logged and unlocked by Ti cannot subsequently be relogged by Ti. That means a particular data item may be logged and unlocked by a transaction Ti only once. Once it has been logged and unlocked, then again it cannot be relogged by transaction Ti. So these are the 4 rules of tree-based protocol. And let's take another example of tree-based protocol in the next slide. So this is the example. Transaction T10 and T11 are given. Suppose just consider the first one. Transaction T10 is given, and this is the database graph has been given. Now whether the transaction T10 is going to be executed or not, and if it execute, whether it will ensure conflict serializability or not. Now first, as per graph-based protocol, what we can do that any transaction at initially can lock any data item. No ordering is required, so it can lock any data item. Initially it locks the data item B. And another thing is that here, if you observe, all the lock are in exclusive mode lock. So initially T10 locks the data item B, as it can lock any data item. Now second time onwards, if it tries to lock a data item Q, then it can lock only if it presently lock the data item which is parent of Q. Means it can lock a data item Q only if the parent of Q is locked by transaction T. Now second item, T10 wants to lock data item E. Now concurrency control component will grant the request or not. It will be based on tree-based protocol. Let's check whether E will be locked or unlocked. It will be locked or lock request will be granted or not. Now the E can be logged by transaction T10 only if the parent of E is logged. Yes, currently, so as the parent of E is B is logged, so E can be logged, means the request is granted. So E is also logged. Next, lock XD means transaction wants to lock the data item D. Again, concurrency control component will follow the tree-based protocol, and it will check whether parent of D is logged or not. Parent of D is B, which is logged, so the lock request is granted. So D is also logged. Now unlocking starts, so it unlocks B. B is unlocked, so B is released. Then unlock E, so E is also released. Now interesting point here is that this is the interesting point. This is not a two-phase locking. Unlock started, again locking can be done, but in two-phase, the moment unlock has been started, you cannot acquire no more new lock. But here in graph-based protocol, unlock has been started, but still you can acquire new lock. Now lock XG, G is here. So again, concurrency control component has to check whether parent of G is logged or unlocked. Yes, parent of G is logged, so G is the locking request has been accepted and G has been logged. Then unlock D means D is released, and then unlock G means the G is also released. So that is how lock and unlock are happening in graph-based protocol. And if you consider T11, check whether T11 follows the graph-based protocol or not. Arbitrarily it can access any data item. Initially starts with D. Yes, D has been logged. Then H request has been made to lock H. Yes, H, the parent of H is D is logged, so H is also logged. Then unlock D, and then unlock H. Yes, it also follows the graph-based protocol. Now the graph-based protocol has some advantages and disadvantages. Let's look at it on the next slide. So first, what are the advantages of graph-based protocol? As I have mentioned, the tree-based protocol or the graph-based protocol, they are same. So the tree-based protocol ensure conflict serializability, as well as the graph-based protocol or the tree-based protocol are deadlock free. In two-phase locking protocol, it was not a deadlock free. Deadlock may happen in two-phase locking protocol, but in tree-based protocol, the graph-based protocol, it is free from deadlock. The next advantage of graph-based protocol is that unlocking of a particular data item may occur at any point of time it may occur earlier in the tree-based protocol, means no need to wait in the shrinking phase. In two-phase locking protocol, unlocking have to wait until the transaction enter into the shrinking phase. That means transaction have to wait for as it moves into as it is move into the shrinking phase. But in graph-based protocol, unlocking may be occur at any point of time, and as the unlocking may occur earlier, means unlocking may occur at any point of time, it has several advantages, like it increase the concurrency, shorter waiting time. Means if you unlock the data item earlier, then what happens, that data item may be accessed by other transaction, so other transaction no need to wait for a longer period of time. That means the waiting time of the other transaction becomes shorter as the data item is unlocked by the transaction, and so that is why that particular data item may be accessed by other transaction also. So that is how it will increase the concurrency level, means many more transaction can execute it simultaneously. And also protocol is deadlock free, no rollbacks are required, but cascading rollback is there. The abort of transaction can still lead to a cascading rollback, but it is a deadlock free. So these are the advantages of graph-based protocol. Next, look at what are the disadvantages of it in the next slide. Now, the disadvantages of graph-based protocol is that in tree-based locking protocol or graph-based protocol, a transaction may have to lock data item that it does not need to access. For example, suppose a transaction need to access only A and J. Suppose transaction T need to access only the data item A and J. So in graph-based protocol, what is happening is that you can access A. Okay, that's not a problem. But if you want to access J, the parent of J is need to be accessed first. This is the ordering. Partial ordering is there. To access J, you need to access first H. Then only you can access J. So H needs to be logged, though it is not required. Now the thing is that to access H, you need to log the parent of H, which is D. So again D needs to be logged, which is again not required. Now to log D, you need to access the parent of D is to be logged, which is B. So again B needs to be logged, again which is not required. That means transaction, though the transaction require only two data item A and J, but still transaction need to log J, H, D, B and A. So in graph-based protocol or tree-based protocol, though some data item are not required to log, but still you have to log the data item. So extra bit of data item, extra set of data item needs to be logged in graph-based protocol. And these are the several disadvantages for that. First, it will increase the locking overhead. Means to lock a data item, we need to do a handful of job. That means it will increase the locking overhead. Then, as the many more data items are locked by transaction, so no other transaction can access the extra set of data items. So waiting time will increase for other transaction. Other transaction have to wait until and unless the present transaction release all this lock. So waiting time of the other transaction is also increased. So increase in locking overhead, increase in waiting time for the other transaction. As other transaction cannot access the data items, so it will potentially decrease the concurrency level. Another important point, schedules that are not possible under two-phase locking protocol are possible under three-phase protocol, and vice versa. They are not same.